Hi everyone and welcome to this tutorial. So today again we are going to be working with SAS BASE, but to make it easier for you to see what I'm typing on screen, I'm going to use SASG, the version that I have. It's 8.1. So please don't be don't be very critical of what you see on the screen. I know it's different from what you usually see. So you guys, I encourage you to use SAS BASE. But I'm gonna be using this one so that you could see the screen really well. And as usual, I will start with a lib name, and it will be libname BST 445, just to tell SAS where to access my data. And I have it here on my C drive, and let me just go here and type it and now run it. So 0 errors. I can check it here. My libname statement, it says that it ran successfully, I guess, yeah. So that's fine, was successfully assigned. So now guys, today we're going to be working with numerical functions, and I'm gonna start, sorry, that's they are the way of writing a comment in R. So we're gonna start with numerical functions that you can use in SAS. Of course, we won't be able to cover all of them because there is really tons of them, but we're gonna go over some of them. So let me first of all print a file. I'm gonna print one file that we're gonna be using today to run a few functions. So it will be BST445, it's in our library, and it's called orders mid-year, and run. But because I don't want to print the full file, I'm gonna just limit the number of observations, let's say to 6. And I'm not using any title here because I'm not interested in running a title. I just want to see what kind of data I have. So if we look here, we will see that actually we have a few variables. We have our customer ID and 6 months. Some of the months have missing values, and some of the months have some data present. So what we're going to do, let's imagine that this is what our customers, this is the revenues that our customers brought us, and we're going to calculate the sum of those revenues to get a total for these 6 months. So there are a few ways of doing it, right? So what we could do, definitely we have to go with the data step, and what we could do, we could say, calculating, again I'm doing this R code style. So what we're gonna do, we're gonna in this file find the total in 6 months or within 6 months. Find the 6 month total, let's put it this way. Find the 6 month total. So that's the first thing. Find the sum of top 3 months by sale. And also we're going to find the max and the mean values within 6 months. So these are our tasks. This is what we are trying to achieve right now by running our code. And it's doable. Like, we can do it in many ways, but I'm gonna show you a few functions that you can use. And that's gonna really help you a lot as you go along. It's gonna save you a lot of time. So let's go without a lot of discussions. So definitely we have to create some data set, right? I'll call it orders mid-year, but I'm just recording it into a work library. I don't want to create a permanent data set, but if you guys want to create a permanent one, go ahead. So then I need this data set that we have in our library, BST445 orders underscore mid-year. That's the file that we have access to. And like I told you, there are many ways of doing it, right? So we're going to create a variable called total, and we're going to calculate it in 3 different ways. So the shortest way is actually just to use the sum function, right? But usually, if you run it in a typical way, you will have to do something like sum, and then you will have month 1, month 2, month 3, month 4, month 5, month 6, So that's your sum function. It's gonna definitely work. It's gonna be good, but I mean, it's kind of like, you know, tedious to write all of these numbers, and I think it's not maybe the easiest way if you have many variables. Right now we only have 6, but imagine you have like 100. That's not gonna be really useful, you know, to do it this way. So another one, we will call it total sum. We're going to use the same function, but we're actually going to add off, and we're going to say that we want to add month 1 dash month 6. So this is a much easier way to do it. And as you can see, you just actually you don't type much, right? So sum of month 1 to month 6. That's it. And a totally wrong way, so we'll say total wrong, to do it is actually just to sum all of these variables, you know, one by one. I'm gonna just copy this because I'm too lazy, you know, to type all of these variables, but I'm gonna replace the commas with a plus sign, and that's gonna be it. I hope you remember that actually if you do it this way, then in this case you actually are not going to have any results. If you have, like, I mean, you're gonna have some result, but it's gonna be like a missing value if you do not you know, if you have missing value, and if you do not use a function, you're going to have a missing value. So let's go for it and let's proc print it. Then we'll come back to this program and we're going to add some more functions here. So data equals orders mid-year and run. Okay, so that's what we want to do. And again, we do not have to print everything. Once we're done with everything, we can print all of the observations. So let's go for it, guys, and let's run these two little programs. And let's see what we have. Let's run. Output data. We don't need it. And the results. Yes. Okay, sorry. I just, you know, it's kind of new, a little bit new interface for me. So let's have a look. So here we have our month, and then we have 3 new variables that we added. As you can see, the total and the total sum variables, they have the same results. It's just we achieve them pretty much in different ways, but you know, one of them is definitely more optimal to use, right? More efficient. And the total run one only gave us one output, and it gave us like how many revenues customer whose ID is 10. How many revenues that customer brought us. So this is all we have, right? All the rest is like represented by missing values, even though we had some revenues within like a few months within this half year. So now let's move on. As you can see, definitely this one is the best. Oh no, this one, sorry. This one is the best to use. Okay, so this is I'll just write. A very useful function, useful summing function for a range of variables. So you're gonna see it in your program later. Okay, so now we're gonna add more, because do you remember, like, we actually set a few questions at the beginning. We wanted to find the sum of top 3 months by sales, right? So how do we find out the sum of top 3 months? For that, first of all, we need to know which months were top, right? And you know, we could sort them, and after that we could do something else. But you know, sorting them maybe is not the best way, because it's gonna take us like to an extra proc step, and after that we'd have to come back, and then we'd have to you know, recalculate everything. So what we're gonna do, we're gonna use a specific function that is called largest, and we're going to apply it. So let's call it sum3, because it's like we are summing 3 months, and we'll say sum, and then it will be largest, and then you're saying that you want the first largest month of month 1, month 6. So that's the first one. Then we'll have the same largest again, but now we want number 2 of month 1, month 6. And the same thing goes for the last month, largest at 3 of month 1, month 6. And we're done with this one. So now let's run and let's see what we have as our output. Okay. So it says ready. So let's check it out. Now we have sum 3. And we can actually check it. Let me just open an Excel file, just, you know, for us to see what we have. Just copy this, copy with, sorry, let me just, you know, copy it all, and I will add it into an Excel workbook, just to show you that we achieved the correct result. So this is our sum, final sum, right? And we wanted to sum the top month from 1 to 6. So if we look here, we will see that our first month with the highest revenue was month 4. So it will be this one. We can use also the sum function in Excel. So it will be month 4. Then we also have month 5 and month 1. Oh, maybe I didn't notice some. Wait, give me 1 second. Ah, sorry, yeah, month 3. So it will be D2. Yes, D2. Yes, now we have it correct. So as you can see, it just automatically, I'm not gonna save it, it just automatically found the month with the highest revenues and then just added them. That's all it did. But you see, like, I didn't do it properly the first time, and maybe I wouldn't even notice that I didn't do it properly. But SAS was able to do it automatically for us, which is nice, which is really great. So now let's continue. And so the next question was, what we wanted to find was find the max and the mean values within 6 months. So basically we're going to look for maximum and minimum values per customer, right? For that you actually have really beautiful, okay, I have to, 1 second, let me just leave a comment. So summing top 3 months of sales. So that's what we're doing here. Now we are gonna, guys, find the minimum and maximum values per customer. So let's start with max, and there is a function called max. And again, if you're using a range, you always have to use off, and then it will be off month 1 dash month 6. Done. So this is the maximum value. I mean, it's self-explanatory, I'm not going to write it. Now min, again, we can use the min function and the same syntax. So month 1, month 6. This is our minimum value. And I'm gonna also show you a few things that you could use. So, you know, we had this sum, right? Sum of revenues, sum of sales, we can say. And, you know, we have more than 2 decimal points sometimes, like in our total. And we're gonna fix it by using a rounding function or a ceiling function, or using also an integer function where we will actually end up having just an integer without anything else. But before that, let's just run min and max so that we could see what we have. And after that, we'll go to the rest of it. Okay, so it's done. And let's see what we have. So this is our max. We'll just go here. And our max is here, $525.80. And that's true. This is like the highest number that we can see here. And the minimum is 191.790. And if we look at this row, we will see that this is the lowest value that the customer brought to the company, and it was month 6. So this is the min and the max function. Now let's just fix those totals, and then we will move on to some other stuff. So let's do it, and let's call total round. Total round equals, and we're going just to round it by using default values. So we'll use total sum. Doesn't matter actually, whatever we can use, like we can also use total. So we'll use total sum for that. And also let's round it to only one decimal point. It will be total round 2 equals round, and we'll use total sum comma 1 or 0.1. And so this is another one. And again, guys, like I'm not going to write many comments here. Here I will write a comment that we are rounding rounding to 1 decimal point, so that you could understand what it is that you're looking at. And the next one will be total cell. So this is going to be the ceiling, and there is a ceil function, and you will tell me what it does. And the next one will be total int. So we're going to just create an integer of our total sum values, and let's see what happens, right? And then I will write the comments once we see the results. Too far. Okay, so let's check it out and let's see what we have. It's gonna be like a super long data set. So okay, now we have this total round where we were rounding just, you know, automatically. So basically what it did, it rounded everything. Seems to be that it rounded properly. So if it was less than 0.5, it would round it down, and if it was let's say greater than 0.5, it would round it up. That's it. So you will get an integer, but also you will get those rounded numbers, you know. So once you specified how many decimal points you wanted, you would get this that many places after the dot, after the period. So you will have here 18,000.0 because you have here 4, so it's less than 0.5, and so on. So it will follow the convention, like it will always round up or down depending on the situation, right? So ceiling doesn't care. Ceiling will, as you can see, will always round up to the next integer. So even if you have 0.4 here, it will still round it up to 1,804, and so on. It doesn't care. And once you ask for the integer, it will basically just truncate whatever you have there. Like it doesn't care what you have after the dot. It just selects or extracts that integer part. So let's move on. Let me just add those comments so that I don't forget, you know, to mention them later. So the ceiling, so round follows a math convention, and this is one, and this one is like I told you, so it just rounds up, and this one rounds, truncates or extracts the integer part. Okay, good. So that's pretty much all we had to do with this file. Now we have it. Now we can actually print the full file. We can give it a title, so we can say title sales calculations, whatever. I mean, we did some sales calculations. Let's also close the title, and let's also add some format. No, it will be total sum. Oh, we have a lot of them, right? Total round, and also total round 2. Too many. Total round 2. Like we don't care about that round part, right? And total ceiling, total int, and we're gonna just create a dollar value. We'll add the $sign to all these things. Okay, so it will be dollar, and we don't have that many values, but let's put it this way. So maximum will be 8.2. I think this should be enough. Let's see if it's gonna be enough. And also let me just switch off this round part. I'll just add the asterisk here, and now it just became a comment. Okay, so let's go and let me do it. Let me run it. Okay, let's see if it worked. You know, I somehow I am always worried about this part. Okay, so it seems to me that yes, indeed, though 8 maybe is not enough. So 1, 2, 3, 4, 5, 6, 7, 8. Yes, I need to add one more. So then we'll have a comma. So it will be 9.2. Okay, perfect. So for the ceiling, even though you see, like, because I used the format, for the ceiling it added those 2 decimal places, which is okay. I mean, that was my request, so that's fine. But what I'm gonna do is, like, just for the future, but I will rerun it, it will be $9.2, so that we could accommodate for the comma as well. Okay, so this is a few numerical functions for you. I hope you see how helpful they are and how cool they are. You know, it's actually really convenient just to say sum of and give it a range, right? I think it's really cool. So this is one part. Now we actually discussed all of these functions so far. So now we are going to move on, and we're going to check out on some values, some extra values. Let's see now, you know, how we can change the length of variables, how can we create a character variable, how can we create you know, a numerical variable, and so on. So what we are going to do now, let's do it. We're going to work with 2 data sets, and we're going to merge them. And for that, you definitely, maybe you remember that you need to have something first of all, they need to have a variable in common, but that variable has to have the same name, identical name, right? It has to have the same length, and also it has to have the same type, right? It has to be either character for both data sets or numeric, again, for both data sets. So let me show you the files that we have. So we have these 2 files. Let me just first type change in name, length, and character or numeric types, right? Okay, so this is what we're gonna be doing now, and let's go. So we have this title, organization, and this data set. Oh, sorry, pro contents, because we want to check what we have here. Pro contents data equals BST 445 dot organization underscore dim. Okay, don't show me everything. And run. And I'm gonna run 2 at once because, you know, they're very similar. So the other one will be title. It's gonna be called orders. This is our title, so that we know what data set we are looking at. Proc contents data equals VST 445 order underscore fact. Run. So let me close the title for both of the files, and let me just run them. Okay, so we have this output here on the left, and let's see. So we have what do these data sets have in common? That's why we would run our proc contents. We could also run it, of course, to check out some information, right? So for example, that the organization data set has 424 rows or observations. It has 20 variables, and so it will give us some other facts. But what we're especially interested at this point is to check what kind of variables it has. So remember that it has 20, and we can check. So we have a company, department, employee birth date, country, gender, hire date, ID, name, term date. So this is all about employees, then job title, and different kinds of manager levels, and then organizational group, salary, and section. So just remember what we have there. And now let's go here. This is the second data set. It has 617 observations, 12 variables, not 20 as before. And so these are the 12 variables it has: cost price, customer ID, delivery date, discount, employee ID, order date, order ID, order type, product ID, quantity, street ID, total retail price. So it has a lot of variables, both of them do. And what they have in common is actually the employee ID variable. Here it's numerical. It has 8, the length of 8, And here employee ID is also numerical and also has the length of 8. So you must have seen that actually we have the data sets that have the variable that is a perfect match, right? The same type, the same length, the same name. There is nothing to worry about. We can just merge them and that's it. But what we are going to do now, we are going actually to make it worse. We are going to screw it up a little bit, and after that we'll go back to normal. So let's go to this organization dim dataset and let's change. Okay, we are going to change actually the length of employee ID, and also we're going to change its type. And yes, so I think it's going to be interesting. We're also going to change its name. So let's go, and it will be the data step. So let me just type here, changing the name, length, and type, and that's what we're going to be doing. So data, we'll call it organization. Here we will ask to drop employee ID because we want to actually get rid of it. Then we will use set BASE 445.organization underscore dim. Actually, we could have done it with any dataset, doesn't matter. So let's create a variable. We'll call it emp ID character. And to create a character function from a numerical function, you have to use put. So we will say put this variable employee ID, the length of 6, that's what we are indicating, and that's how you create a character function. And after that we are going to create a new one. We are going to create actually a numerical function from it later, but for now this is it. So let's run and let's see what we have. Okay, proc print data equals organization, or actually we don't need proc print. Let's run proc contents. Data equals organization, sorry, run. Let's see if it worked. Okay, so what do we have now? So now we should have the variable called employee ID char, right? Emp ID char. Its type is character and its length is 6. So that's exactly what we wanted. We wanted it to be different, and now we have to solve this issue. So imagine this is the original data set that you were given, and now you have to merge this data set with the other one, with the OR defect. And now you will have, you know, your OR defect data set. Let me just copy it and you will see, right? So now you will have your order data set with order facts. And here let me just also create a title, bad data set or something. And let's run, and again, so let's see how different they are. So now here we have this employee ID. They basically contain the same information, but our employee ID, so this is the bad data set first, yeah. So here they contain the same information. So here we have emp ID character, the type is character, the length is 6. Here we have the variable called employee ID, so the name is different, it's numerical, the type is different, and the length of 8, so the length is different as well. So what we have to do now, we actually have to change it. We have to reverse this change, and here's how to do it. So let's create another data step. So fixing the variable, and actually we are not going to change the name now. We are going to use it later at the merge statement. So we don't care about the name. It's not as important. but there are some things that you cannot change, you know, when you're merging data sets. So let's just, you know, go for it here, and then we'll fix some stuff that we can fix at the merging step. So the first thing we're going to change is this. We're going also to call it, like, let's say org. Okay, so data org, and the set is going to be organization. So here, before we created the character variable, now we're going to create it a numerical. Now we're going to reverse it, right? So it will be amp id, and we'll call it num equals. Instead of doing put, you will just say input. And now you have to use your character variable that you created before, and you have to indicate its length, and that's pretty much it. So that will be run. We actually do not have to change the length here. It's not as important, but we can also ask SAS to change the length before we go any further. So we can say, okay, so once you're doing this amp id num, make it 8. And it's gonna overwrite what we asked for. And now let's just run proc contents. Data equals org. We are just gonna run this one and just we'll see what we have here. Okay, so let's see if it worked. If not, we can always fix the code. So now we have this amp id num, and it says, okay, so the name is different, but now at least we have the same type and the same length, right? This is actually, that's a lot already. Okay, so let's go. And now to merge the data sets, if you remember, we have to sort them first. And that's what we are going to do first, okay? So actually here I could write the title, something like checking the format, and just close the title. Now merging data sets. So let's start with proc sort. Proc sort data equals. If you remember, we're going to definitely sort them by our common variable. So it will be in one case amp id num, and then the other one it will be employee id. So we're going to sort our org data set, and we'll create a new one, out org underscore sorted by amp id num, and run. So this is one. We don't care like if it's ascending or descending, they just have to be in the same, sorted in the same way. Proc sort data equals, and it's bst 445 order underscore fact out order sorted, and by employee id. So that's what we are looking for. Run, and then we'll just right away I will write the merging statement. But guys, it always makes sense, you know, to go step by step. So let's check out. So sort didn't give us any errors. We can go to the log. No, it's okay, 0 errors. That's fine. And again, we can also sort this one. We can also check exactly what the log told us, what kind of procedure was used. You know, sometimes like they tell you if something bad happened, some observations were lost. So here we do not see that it encountered any problems. So that's good. So we sorted those files. Now let's move on. Let's move on to the merging. So it will be data, and we'll call it, for example, organization orders. Organization orders, and we'll use the merge statement. So what we're going to use here, we're going to use org underscore sorted, but then we will see that we will have to decide which variable we should be using, you know, so we're going to use it later. So order underscore sorted, so these two data sets, and the common variable should be something, you know, it has to have the same name, right? So I will choose employee ID, And that should tell you that actually we have a problem here, because if you are saying by employee ID here, one is called this way, so we do not worry about the order sorted data set, but we should be worried about this one that has the variable called empid_num. And before we proceed, we should actually rename it. So we'll say rename, and then we'll put the equal sign and then open the brackets. And at first you have to say, you have to specify your old name, empid_num. Let me just type it here. Equals employee ID. Okay, so remember that we opened two brackets and we have to close both of them. And that's it, no commas between the data sets that we are trying to merge. And right away we have to also print them just to see what we have, you know, what we created. So title, organization, orders within the organization, I don't know, whatever the organization is called, and proc print data equals organization orders _ orders. Sorry, because of these prompts it's really difficult to see what is going on, and just run. So let's also close the title just in case, you know. So here I could add merging datasets and renaming the variable. Okay, so here sorting, I mean, okay, let me just say sorting datasets. Data sets. Okay, so now let me just run it and let's see what we have. And also I don't want, because the datasets are long, right? I don't want them to be super long. So let me just here specify the number of observations. I'm not specifying any condition here how I would like them to be merged, but they're gonna be merged, you know, as an intersection. So let me check out what we have here. We have here everything from the previous data set, and then employee term date, empid. Okay, so we still have that empid car. We can drop it, we don't need it anymore. And actually that's what I'm gonna do, but also it's interesting that we do not have any information about the order type and stuff. So let me see what happens. 12, okay. So let me just check out the data sets by themselves, okay? Data equals org sorted, right? Run, and also, and again, let's only see like a few okay, let's actually check out all of the observations to see if it makes sense. So this is the first ID. Okay, we have like different manager level and stuff. So let's also check out the other one. Let's check out the second proc print data equals BSC 445. Sorry, we don't need it. We actually need to use order sorted. Okay, order _ sorted, and run. So let's also check out the full data set just to see what is going on there with different IDs. And I'm interested especially in this 12, like we sorted them by IDs, right? Employee ID. Okay, so this is our first employee ID, and has multiple duplicates because it has many customers. So some of the customers didn't make any orders, but also some of the customers did, right? Okay, so this is interesting because we see like no information about this employee with this ID. So this is an interesting data set. So maybe before we actually even could sort anything, we should have also thought about you know, how we could aggregate the data, you know, but a lot of things, right, going on. So it depends on what we would like to do, but yeah, I think we should actually merge them by the orders, and that's what we're going to be doing. So we'll say in equals b, for example, or a, doesn't matter, and we will say if a. So now this is going to be the main data set. They will be sorted, they will be merged in this order, in this particular order, where the first data set will be org sorted, but then the second data set will be order sorted. But this data set, so everything, like all this merge, is going to be based on the employee ID that is coming from the A data set, so from the order sorted data set. Okay, so let me check now what happened here to this data set. Okay, now we have all the information complete, because before we had like a lot of missing values. So now we have employee ID, country, department, section, job title, employee name, gender and stuff. But we also have the order data as well, right? So that's perfect. That's exactly what we wanted. And this is an interesting data set. What we could be doing now, once you merge those data sets and stuff, now we could actually do a lot of useful things with it. We could calculate the mean, or we could sum all the information, in this data set, but we are not going to do it now because this is not the purpose of this tutorial. So let's continue. And what we're going to do now, we are going to focus on one data set. I'm going to print it for you. So character functions. And this data set is really interesting because you will see it needs a lot of fixing to be done. So it's called address. So I'm going to give it this title. And proc print data equals bstf5 address run. Sorry, run. Let me just print it. And let's see what we have. So what we have is this. We have basically just 2 rows of data, but you can see how the person was entering the information. So Ron, Cody, it's not properly entered, it doesn't follow the convention, right? Where you have to start each name and last name with a capital. Also the addresses, they're not consistent with entering the address. The same goes for the city. The state is in all lowercase letters. So that's really not exactly like a data set of your dreams, and we're gonna fix it right now. So let's go, and let me just close this title, and let's fix it. Okay, so we're going to create a new data set. It will be called address, but we are not overwriting the one in the library because this one is in the work library. That's what we are doing. So set is called bstf5 address, and now we are going to be creating new variables. So it will be name equals. So as you remember, the first problem that we had was with the name, right? So to fix it, you can use prop case. And prop case, what it does, it just fixes the way you write your words. So it will start each word with a capital letter, and that's exactly what we need in this case because we have names, right? So the next one, we are going also to use the prop case on the street names, on the street address. So we'll call it street equals, and again prop case. So we are basically just overwriting the variable, right? And the variable is street. Not street. Okay, good. The next one is city. It's the same, there isn't much we can do. Prop case city. And state is gonna be uppercase. State uppercase because we actually want both letters or both characters to be capitals. So state. The zip is okay, so we're not gonna fix it. And now let's give it a title, something like fixed, improved addresses. Okay, and proc print data equals address, and then just run, right? And let's close the title. So let's go and let's see how it works. If it worked, actually. Usually it does. Yes, you see, so now we have this really beautiful data set where you have the name that starts with the capital letter and the last name as well. The street as well looks pretty good. And the city and the state has all caps. So yeah, we did it. Good job. Now let's move on. So this is, let me just, yeah, by the way, so start, let me just add some comments. Start each word with the cap, and here write all caps. So sometimes you actually need to write all in caps, right? Now let's move on and see another data set. This one is also interesting, so let me just show it to you. So title, oh sorry, title, customers, proc print data equals BSTF5, and it's called customer dim. So it's the information about customers, and that's what we're going to see, to check out. Let's go and let's see what we have. Customer dim. Actually, sorry guys, like I printed too much. Let's just print out a few observations. We don't need all. We only need, let's say, 6 or 10, you decide. So let's move on and let's see. We have here the customer ID, their country, gender, their name, but we also have their name and last name separate, right? Customer first name and customer last name. And my goal is actually, what I would like to do, I would like to combine these two names to create a full name. That's what I would like to do. So let me just give here some title, creating a full name. And that's what we are gonna focus on right now. For that, you also have specific functions. What they will do, they will basically concatenate the variables that you have, and they will combine them and they will place them into the same column. So let's see how it works. I just want to show you a few functions, and I also want to show you something that you can actually use, you know, to see what is going on behind the scenes, which is also nice. So let's go and let's create a data file which is called customers, for example, and then set BSTF5 customer underscore dim. So this is the beginning. Now guys, let's create a few so that you could actually see what happens when you run this or that function. Okay, so we have here a few variables. Let's see what they're called, because this is critical. One is called customer underscore first name, no underscore later. Customer underscore last name is the name of the second one, and we're going to combine them, and we're going to start with the first name and then add the last name to it. So let's go. So name join. This is I guess the easiest way to do it. Let's just say customer underscore first name. SAS is actually case insensitive. Like when you're speaking about variables, you can write them any way you want. I'm just doing it, you know, for aesthetics reasons. So that's all. This is the only reason why. So customer last name. So this is one of the ways of concatenating the file. So what you're saying, like add here a space. That's it. And that's what SAS is going to do. So the next one will be name cut. And we're using the special cut function. If you have a cat, it's easy to remember. So then customer first name, comma, customer last name. Here it doesn't matter if you leave a comma or if you don't. Just leave no spaces, and let's go. So customer last name. The next one will be name cuts. Again, this is another function that we have, and we'll say customer first name. See, it tells you what it does, and then customer last name, And that's pretty much all you need to do. So here you do not leave any spaces, and it is not gonna, you will see what is going to happen. And the last one will be called name catx. It's actually my favorite function because it's kind of the most accurate, you will see. So now customer first name and customer last name. So what happens here is that you're indicating what you would like to leave between their name and the last name, and it's going to be just one space, and you will see how elegant it's going to look like. So what you could also do, you could actually also ask it to print into the file, and pretty much you will see that it's going to print it into your log, and you will see what is happening. So if you use file print, then if you say put name underscore join, then equals, then name, actually I'm just gonna copy them, name cat, and again equals slash name cats, you're going to see everything that is happening behind the scenes, because sometimes you cannot see it in SAS when you just look at the data set, and you will see actually here that sometimes you do not realize what just happened, but printing it into the file is going to help you see it. So that's pretty much it, and now let's go for run. So again, we have a few ways to join. You can use just the regular join using just, you know, these bars, vertical bars. Then you can use the cut function, then you can use the cats function. And here, as you can see, right, so it removes leading and trailing blanks. So if you have some blanks in your cells, it's going to remove them, and it will give you a character string which is going to be concatenated. And also catx, it removes all of the blanks, and it, like as they say here, right, it inserts delimiters, and that's pretty cool because you can choose your own delimiters that you want to run. So now let's proc print it. Let's give it a title improved or created names, created full name, let's put this way, and proc print data equals, what did we call it? I always have bad memories. So customers, and run, and title, I'll just close it. Okay, so now let's see what happened, and also we're going to check our log as well. Okay, so this is what we have. This is our results. This is when we ask to print it into the file. That's what happens. You can see that each name is here, but you can also see that if you use the name join, you have James and then a long distance between them, and then you have the last name of the person, right? If you use name cat, you will have actually again a lot of space. If you use cats, you have no space, which can be useful sometimes. You know, let's say you have a suffix and you would like to attach it to the string that you have, and here you have like the best version. But if you look just at the output, you know, if you just look at the results in the file, you will see that you do not see the difference, honestly. So let me just go to the side, and where do we have it? Yes, like here, just because of the way it shows up, you cannot see much, because you know, like you do not realize that you have a lot of spaces here. Here, yes, you do realize that you do not have anything, but here you also don't realize. So these, all of these three, join, cat, and catx, all of them look the same, and only using the file print you can see that they are not the same. They're actually very different. Like here, catx, beautiful, you know, you just have one space. Here you don't have any space, and here you have lots and lots of blanks, right? So that's not exactly what you would like to show in your report. Okay, so let's move on, and let's use another one. Now we're going to go for strings of data. Oh, sorry, I was going to actually work on the program, and instead I was working on something else. Okay, so strings. Strings are also important because a lot of data is written in strings, and I mean, like a name is a string, or a last name is also a string, and so on. So we're going to go again for this customer dimension file, and we are going to do something really fun. Let me just show that file to you again. We saw it before. So our goal will be to go for their birth date and basically just, you know, separate the birth date into 3 different parts. Was a date that I wanted to go for? I think that was, yeah. Yes, so we're going to separate it into 3 different parts. It's going to be, you know, the day, and then the month and the year, but all of them are going to be character variables. And also we're going to scan different, this is customer dimension, right? Yeah, so we're also going to scan the customer name, and we are going this one, and we're going to extract the name and the last name. So we're going to create two variables out of it. And yes, also we're going to go into the name that we are going to actually create, and after that we'll replace a value there with another value. So you will see how it works, how it goes. So let's go. So data customers 1. Let me just move it to the side. And the set that we are using again is the same, bs345 customer underscore dim and date. So date, sorry. As I said, we're going to create a character variable out of it. So we'll use put, because all of the variables are pretty much character variables. Oh, sorry, all dates are numerical usually. So what we're going to do now, because we're going to work with strings, we're going to make it character first, and after that we're going to transform it. So it will be customer underscore birth date, not transform, but work with it. And then date 9, so this is the format. And how do I know it? Just because I saw it, right? I saw the way the date was written. If it's written this way, the format is date 9. So that's pretty much what I have to tell SAS about it. And now we're going to use this newly created variable in a few operations with strings that we are going to apply to it. So the first one, we would like to extract the first day, the first value, which is going to be day. So we'll say substr, right, date. So we are saying that it has to start at number 1 and has to finish at number 2. Luckily, you know, we have this consistency. We know that the date is maximum two numbers, 2 digits, so we can do it. We can afford to do it. So the next one, we are going to subtract month, and month is again substring, and we'll go for date. And again, the place where it should start is number 3, and it should execute only the length of 3. Yeah, so it has to extract 3 characters from our substring. Okay, so it starts at 0.3. Let me just show it to you what it means. So here, you know, we are telling, okay, so go start here at number 1 and extract 2 things, right? The length of characters has to be 2 of the new variable, right? Then we are saying, okay, so start at number 3, including 3, and extract 3 characters. And then we'll have to start at number, so 1, 2, 3, 4, 5, number 6, right? So position 6, and extract 4. So that's the goal, but we do not have to say, like for the ending one, we don't have to say how many it has to extract, as long, you know, as this is the last one, right? So we'll just say extract date 6. That's it. So to indicate how the length, you don't have to, if you know that this is at the end of the variable. So now first equals, and we're going to scan and look for the customer name and extract the position 1. So if we look at the customer name, it has two strings, right? So we're asking to extract string number 1. That's it. So now we are going to use last equals, again, scan customer name. It's very easy, you know, you just say what you want SAS to extract. That's it. So by default it knows that the delimiter is space, so that's it. It will just extract it. So this is what we are going to do so far, and let me just also run it and print it. Customers 1 run. So also I'd like to add the title strings, let me just call it like this, extracted. Okay, so let's go and let's run and let's see what we have. Okay, so at the end we have our day. Yes, and that's pretty accurate. Then we have our month, and again, no mistakes here. We also have our year, and we also have the first and the last. Okay, so here we also have a customer whose last name, no, his first name was Avinoam. Let me just find it for you. Avinoam. I mean, we don't have that many observations here, so that's fine. We have Avni, and yeah, Avinoam. So this is the customer, and actually, I don't know if it's 2 or 1. Difficult to say because we have different years and stuff. So what we would like to do, we would like actually to find this name, and we would like to replace it with another one. We're going to give it a nickname, something like that, right? Avi. I'm gonna just add another variable. It's not going to be exactly the variable, so I'm gonna override the first variable that we created and use trend_word, the trend_word function. So what you have to do, you have to say what you want to take and then what you want to replace it with. So it will be trend_word first, comma, and because this is a character function, you have to use quotation marks, Avinoam, and replace it with Avi. And we'll see if it worked or not for us. Okay, so let's go and let's print it and let's see. Did it work? Did it not? We will see it. Okay. We could maybe also use something like procfrag and stuff, but let's not do it. Yeah, so now you see these two guys, they got replaced. Also we have more here. So yes, it worked. This is about these character functions. There are a lot of other useful things that you could do. You could also, like, we could also check it by using procfrag. Let me just title checking names. Procfrag data equals customers 1 and run. So let's just run it and let's check here. Oh yeah, I forgot, guys. Yeah, sorry. I actually should have just indicated tables. Sorry. Tables first. That's what I want to do. I don't want to do anything else, so let me just check the first name. So we have Ahmed, Alex, and other people, and we also have Avi, which is good. We could also check procfrag and data equals, what do we have? It was BSTA for 5 customer underscore dim tables, and was customer underscore first name. So we can also check it this way. Now if we check this one, we will see that we had that name before. Avinoam was mentioned 4 times, but once we ran this one, we actually have it mentioned 4 times as well, but there is no Avinoam anymore in our data set. Okay, so now let's move on. And now let's use let's clean our data set a little bit. Not too much, but let's just clean it a little bit. Compress function. This is a really cool function. Honestly, I'm a fan of it because it helps you to get rid of the data you don't need. Sometimes, you know, people add a lot of stuff in one cell and you don't want to see all that stuff. So let's see what we have in our data set. Well, it's called cleaning. I'm also gonna create a title like this. Procprint data equals BSTA 445 cleaning and run. And let me just close the title. So let's see what we have on the data set. And the data set is really interesting because it has here letters, right? Apple, ice, 9, help, exclamation mark. And then numerals. It has an X here. And both, yes, it has a combination, but also it has a period here, which is neither a letter nor a numeral, right? Nor a number. So what we're going to do, we're going to get rid of the digits here. We're going to get rid of the letters in the numerals, and we're going to get rid of the period in the both. And we will also combine some functions together so that you could see how you could go about it. So let's go and let's see what we could do. So we're going to say to call the file new and improved. I'm in marketing, you know, so I have to use it sometimes. New and improved. And the set is bsta 45.cleaning. And now let's fix this, right? So at first we're going to overwrite our letters, and we're going to use this really amazing compress function. So what you have to say, you have to indicate what you want to compress. After that, you just have to leave here, you know, some space. I mean, that will tell that you do not want to overwrite it with anything, and you will just use PD. And let's see what happens. So let me just show you what happens. Title, compressing, variables. We'll just go step by step so that you could see. Proc print data equals new and improved run. So let's run. So you said actually to remove only digits, and that's what it did. Digits were removed. Now the next one, we have to worry about keeping the digits actually, right? So here, let me just add here the comment, because this is important. And I will say get rid, yeah, and also, yeah, true. So you have to remove, P means, P stands for the punctuation. So remove the punctuation and digits. Get rid of punctuation marks, and digits. Now we actually want to keep the digits, and for that we have another option. So we'll call it numerals. Again, we're going to overwrite the variable we have and use the compress function again. Numerals, again, do nothing except for this KD. So KD stands for keep digits only. Let's see what happens. Now we don't have that X here, so we only have like numerical values over there, and now we want to compress both, and we also want all of the letters here to be uppercase. So we want to get rid of the punctuation, and we also want to get rid of this improper casing, you know. So both equals uppercase. First of all, let me just use compress. Both, comma, and we can indicate that we actually would like just to remove the period. That's all. So you don't have to use anything else. You can be very specific. We only have a period, so you see now it got removed, but it still doesn't look nice. So we will just use uppercase, and we will apply it to the compress function. So it's like a nested function that we're creating. And now the data set that we were working on, now it looks really good. So that worked. Okay, so here let me just add keep only digits, and here remove the period, and uppercase. Okay, so that's pretty much all we had to do with this, but I'm gonna also add another one, another really short exercise or activity. So we have a data set, it's called customers x5. Let me just show it to you. So again, applying what we learned. So what we're going to do now, let me just, before we go into this data set, we have to have a look at it. So title, Orion clients, and proc print data equals BSTF over 5 customers x5 run. So this is what we're going to work on. We should have definitely not printed that whole data set because it's pretty long. Okay, so we have this customer ID, we have name, we have country, gender, and birth date. So have a look, guys. Like sometimes we have, you know, this silver, which stands for the customer's membership, let's say the gym, because Orion is a gym. And you know, also what we have is that we would like to replace these 2 zeros with 15. So right now our system is changing and we would like actually to include 15 instead of those 2 zeros here. And also we would like to create, based on the variable, based on the membership, we would like to create 3 data sets and place each of our customers, for example, those that belong to the silver membership class, we would like to place them into the silver data set. Those that belong to the gold membership class, we would place them into the gold data set, and so on. And also what we have here, guys, you saw it, right? That the variables like platinum, silver, and stuff, they're not written in the proper way, right? So the formatting is not the best. I mean, like platinum is written with the small letter and stuff. Let's also look at the names. They are not also the best either, right? So we also have to fix that. We will use the prop case to work on that. The country, the gender, they seem to be okay. I mean, we don't have like a long data set, so that's like we can check it manually, but yeah, there are definitely ways to do it automatically, but we just did it manually. So let's go and let's create 3 data sets. One will be called silver, one will be called gold, and one will be called platinum. And we're going also to use the conditional formatting for that. So we're going to ask SAS to actually apply some conditions, very specific conditions. So we're going to use the set BSTF over 5 customers underscore x5, and name, that's what we're gonna fix first, prop case, like we discussed it before, right? So if we apply prop case, let's go step by step. We're going to see certain results right now. Prop print data equals, we'll call it, oh sorry, this is going to be, first of all, oh, it's difficult to decide which one. Okay, so right now let's just create one data set, okay? So new, data equals new, run. After that, once we've solved everything, we're going to go over it again. So Control Fn F3. Okay, so that's perfect. Now the names look much better. We are also going to apply it to our customer ID, which is not ID really for now. So customer underscore ID is going to be also prop case, and customer underscore ID. Okay, perfect. So let me just move it a little bit, and we will see if it worked or not right away in the output. Okay, so now all of the names of the programs are written with the capitals, which is fantastic. That's exactly what we wanted. So now what we're going to do, we're going to actually first of all replace the customer ID here, the digits like 00 with 15, and for that we'll use the translation, the translation word function, right? So customer ID again, customer ID, do we need to create a new one for this? Prop case, I guess we could imply actually prop case once we have done that replacement. So we'll just apply prop case on top of that. So it will be tran a word, right? That is word, customer underscore ID, comma. And remember that even though we have digits there, it's still a character function because we have also a combination of letters. And every time, once you have even one letter, it becomes a character function. So that's what we are going to replace with this 15 dash. Okay, perfect. And yes, that's what we need. Okay, let's go for it, and let's see what we have. Let me also give a title new, and okay. So now let's rerun and let's see what we have. What? Ah, yeah, sorry. This is my problem sometimes. I forgot to close the second bracket. You see, like I did it with the first one, but I forgot to close the prop case brackets. And let's see what it would have taught me. Oh, what actually it did tell me, right? So it says that it's expecting in brackets error 79322, and here it showed to me that there is a problem somewhere there. Okay, so that's perfect, and let me just rerun it. Hopefully it will work this time. Yes, it did. Okay, so yes, now we have 15 instead of those 2 zeros that we had before. Okay, so let's also do something else. Let's go for let's create a new variable, and we'll call it membership equals, and we are going to use the function we used before, if you remember, the compress function. Compress, and what we're going to compress is customer ID, and what we're going to keep there is just we're going to remove everything that is not a letter. So let's see how it works. Hopefully it will work for us. So let me see. That new variable has to be okay. Now yes, we have our silver, platinum, gold, and stuff like that, you know, written in the membership. So not everybody is a member, I guess, of our gym anymore, but we were able to subtract or to extract that variable. So that variable name, right? So category. So let's move on, and now we are also going actually to use the customer ID. Yeah, also we're going to actually use the customer ID, but we're going to improve it a little bit. So maybe what we should be doing, maybe let me just move it here. So membership, compress customer ID, and then apply it later. Change it, or let me just call it maybe an ID, because I would actually like also to create a beautiful ID using again the compress function. So compress, but in this case I only want SAS to keep, sorry, let me just, you know what, I will just keep this at the beginning. Let me just, okay, yeah, so I'm gonna keep it. I know it's maybe not super cool that I'm keeping it, but you know, still, like, for you to practice, this is gonna be useful. So ID equals compress, and I'm going to compress customer ID again, but in this case I will just keep digits only, and that's all I want to keep. Okay, so I don't want to keep anything else, just the digits. I'm creating a new variable and it's called ID. Let's see again. So you will see actually that it is pretty efficient if we do it, right? So now we have a beautiful ID, only digits, and we also have the membership that has only words, right? Okay, so that's about that, and let's move on. Let's do something else. So now we are ready to create our 3 data sets: silver, gold, and platinum. So of course we could just use, you know, if, and then say that if this function or if this variable has this value, we're going to use it, but we're going to use the find function instead. So we'll say if find, and we're going to use our customer ID. If find customer ID, comma, silver. You see why the prop case was important. And we are also, just in case, we're going to say that the casing doesn't matter, so we'll use just the I letter here. Oh, sorry. If find customer ID gold, then output gold. Okay, so let's see. Let me just replace this with this. Okay, maybe I shouldn't be there. Okay, yeah, it's okay. So let me just see what we have now. Okay, so we have gold. Do we have gold? Then we have silver here. Okay, just silver in our gold file. Okay, so if find, yeah, because I said so, sorry guys. Then output silver, that's what I meant. Okay, then output silver. And yeah, why did I use gold? I don't know, don't ask me. Okay, so title silver and data silver. Okay, so now we are going to continue. We're going to use our else if statement, find. So it will basically just search within the customer ID variable, and it will be looking for what we need. But you know, because like even though we use the prop case function, imagine you didn't use it. So using this I symbol that ignores the case is a very useful way of actually avoiding some problems when you will not include all of the possible representations of that category in your data. You know, like for example, platinum can be written with the lowercase letters and with lowercase letters or maybe uppercase letters. You don't know. So just to avoid that problem, you will basically just go, you know, for any case, which is perfect. So now we have gold. So if gold I, then output gold, not golf, gold. Okay, yes, finally. Let me just open it so that you could see the full code. Perfect. And else, if we cannot say here just else, because we actually would like to output only 3 memberships, right? So else find customer underscore ID, and not gold this time, it will be platinum. Knowing myself, I can make mistakes sometimes when I type. Then output platinum. We could also create the 4th data set, and we could call it the rest. Okay, so let's say now we can actually say else, and then output, just else output the rest. Okay, and we could create 3 additional prop print statements. So one will be silver, one will be gold and gold, another one will be platinum, and the last one will be the rest, so that we could kind of sort all of the observations into these 4 data sets. And let me see how it goes. Okay, something ran. Let's see if it worked or not. So we have our silver, and everything that we see here is silver. Then we have our gold, so we only have 2 gold members. And we also have our platinum, And then we have people who do not have any category assigned to them. This could also be like a very useful list. It could be either consisting of the clients who left the gym, or it could be consisting of the clients who maybe they didn't have their data properly inserted, or perhaps it's also possible that we may want to contact these clients and, you know, suggest them to upgrade their membership in our gym. Maybe, you know, silver, gold, and platinum. These are not the basic membership subscriptions, so we could actually suggest that they update, and this list would be really useful. So that's pretty much all we had to do. Let me just show to you the code again. Sorry, the code, not the data set. But you see that you can create 4 or maybe more. You can create multiple data sets in one data step, and you can use a lot of conditions. You can compress the data. We did all of that today, and thank you all guys for your attention. Good luck. I hope it was useful for you, and I hope to see you actually before the semester is over.